So the scientific method. So in this section or lesson, we will focus on the following learning outcome. So students should be able to review and reflect on the skills and thinking used in carrying out investigations and apply their learning and skills to solving problems in unfamiliar contexts as well. So basically what this is about is thinking about the skills that scientists use when they go about when they're curious about something, they pose a problem, they turn it into a hypothesis, and then they carry out an investigation. So that's kind of like what we're going to look at. So we're going to focus on the water cycle within this section. So if we have a look here, so this is a picture of two people out kayaking, and what we can see is they're kayaking on a body of water. And what we can see then here is that we have this kind of a mist that's forming just off the water. So the question is, what causes this mist that we see, and can we model it, and can we investigate it? Okay, so what we know is that they're kayaking on a substance that we're fairly familiar with, which is called water. So this is what water looks like. So water is water, and its scientific name is H2O. So this H stands for hydrogen and O represents oxygen. Okay, so like this. And this is what a water molecule looks like. You have an oxygen atom that is connected to two hydrogen atoms. Okay, so you have these atoms that are joined together. And what happens is these molecules are extremely small. And what happens is they align with each other. So basically, if we look at this, we can see that the oxygen, when it's bound to the hydrogen, it's slightly positive, and the hydrogen, when it's bound to the oxygen is slightly positive. So we have this negative piece and this positive piece. And what happens is when water molecules come together, the positive part is attracted to the negative part. So what you get then is you get these different arrangements of water molecules. So what can happen is you get these things called states of matter. So when it's really cold and when there's very little energy, okay, within the body of water, what's going to happen is it's going to turn into a solid. And what happens in a solid is that the water molecules or water particles are bound really tightly together. So they kind of form a structure like this that's really tight together. And they're not able to move around or move over each other. Now, in a body of water, so if we take that ice and we heat it up and we add energy to it, what's going to happen is it will turn into a liquid. And this is kind of like what a liquid looks like in relation to the water molecules. So the water molecules are not as rigidly held together, and the water molecules can move past each other and over each other. And that's what gives it the properties of water. And that's what these people here are kayaking on a body of water. And then if we continue to add some heat, okay, we continue adding heat energy into this, what's going to happen is these water molecules will be able to move further away from each other. So they'll be able to get away from the positive and the negative charges from each other. And what's going to happen is they will spread out further apart, and the water will start to evaporate and it'll start to turn into a gas with energy being added to it. And this is kind of like what the water molecules look like when you add enough heat energy to allow them to get away from each other in relation to their positive and negative charges. So remember, like this oxygen here is going to be attracted to this hydrogen here, and if they're close together, they're going to come closer together, and then if you continue letting these molecules come closer together, they'll turn into ice. And that's essentially what happens when you are heating up liquid or freezing liquid. Okay, so you're either taking out energy or you're putting energy into the body of water, for example, and that causes what are known as state changes. Okay, so states of matter. So this is the way that the water can exist. So this might give you some idea of what's actually happening here. So if we think about this body of water that they're kayaking on, the water molecules are going to be like this. Okay, so they're going to be arranged like that. They're not going to be completely solid like this. It was a solid lump of ice, and that enables people to be able to kayak across it. But what's happening is if you add some more energy to this body of water, what's going to happen is the water molecules on the surface of the water here, okay, they're going to have enough energy to escape the other water molecules that are underneath them. Okay. And what they'll do is they'll start to turn into steam. So essentially what you're going to get happening is water is going to start evaporating off this body of water. And this forms mist. Okay, so all of this here is essentially water particles, but it's just in a different state. So where does the energy come from, do you think? Well, the heat energy is actually going to come from the sun. So the sun is going to heat up the body of water. Some of the water will evaporate, it'll turn into steam, and then eventually what will happen is that steam will cool down, it'll turn back into liquid, so that will come back down as rain, and you'll get this cycle that will start to happen. So this is what's known as the water cycle. So what causes the mist that we see? So we can say that a change in phase, okay, brought on by heat being added to the water, turned the liquid water into gas. And can we model it and can we investigate it? So what I'm going to be getting you to do is you're going to actually build a model that you will use to demonstrate, for example, how the water cycle actually works. And we're going to look at it so we're going to take this question and we're going to turn it into a hypothesis, and we're going to build a model and investigate that and think about the skills that we will learn and what we learn about the water cycle as we go through that. So that's kind of just setting it up. So this is just really just an introduction to, for example, atoms and water molecules and states of matter. And we will learn more about this as we move on and we start to look at a model to demonstrate how the water cycle works. So if we look then at the water cycle, so this is the water cycle basically, and if you take a look outside, for example, it's what basically dictates rainfall, and it has a big influence on the weather, for example, and the weather systems. So there's 7 named stages to this. So we've stage 1, 2, 3, 4, 5, 6, 7. So you have evaporation, condensation, precipitation, which is rainfall. Now that can also be, depending on how cold it is, it could be snow, or it could be sleet, or it could be hailstones even. Stage 4 then is infiltration. So this is where the rain soaks back into the land. Then stage 5 is runoff or collection. So what happens is that the excess water that soaks into the ground will evaporate, will be sent back or run off back into rivers and lakes. And then you have transpiration then as well. So transpiration is basically where, if we take plants, for example, so plants use up they take in water through their roots, and then what happens is excess water then is evaporated off the leaves. Okay, and that's what's known as transpiration. Okay, so pause the video, have a look at this, and just have a look at this diagram here, which kind of explains the water cycle. So what's happening? Okay, so we start off with a body of water, and then we also start off with water that's like excess water that's on any of the green plants. What will happen is the heat energy from the sun is going to heat up the body of water, and it's going to heat up the plants as well. And what will happen is you'll get evaporation and you'll get this transpiration as well. So basically what's happening is the liquid water is turning back into a gas, and it's being evaporated into the air. And what will happen then is that will gather in the air in clouds. So if you look up at the sky, for example, and you see clouds in the sky, there could be tons of water above your head in the form of a cloud. And what's the difference in that and a big body of water that's in a lake? It's just the state of matter that it's in. So it's in a gas form. And what will happen now with this? So this condensated or transpirated or evaporated liquid will stay up in the sky as clouds, and it'll be moved around in the sky as clouds. And then what will happen is, so this body of rain, like this body of water, if you like, it'll be transported over to colder regions, if you like, within the sky. And then what's going to happen is, if it's cold enough, then depending on how cold it is, basically what will happen is the energy will be taken out of these clouds. And what will happen is the water will become too heavy to stay in the sky, and the force of gravity will start to bring it back down to the earth in the form of rain. Now it depends on how cold it is. If it's really cold, you could get sleet, or you could get hailstone, or you could even get snow, depending on the temperature. So what's going to happen is that this evaporated water is going to condense, and it's going to come back down to the earth when the temperature cools down. So you're going to get you're going to get this, what's known as precipitation or rainfall. So the water will fall back down to the earth, and what it'll do is it'll soak everywhere. And what's going to happen then is some of that water will be infiltration or soaked or infiltrated into the ground, and then it's going to be run off back into like rivers and lakes and back into the sea as well. And then some of that water will be taken up by plants, and then what's going to happen is the excess water will go back onto the leaves, and you'll keep getting this cycle that will just keep happening over and over and over and over. So basically the water that's being recycled has been here as long as the earth has been here as well. So this water just keeps getting reused and recycled by nature. So this is, very briefly, this is what the water cycle is. And what we're going to do is we're going to do an assignment where we're going to build a model that demonstrates how the water cycle works. So that's an introduction to, so for example, now what we want to kind of think about is how does science work in relation to trying to answer kind of questions like this and explain this. So we have this model here, and how did this model come about? It came about from scientists being curious about how it works and then developing a model in relation to how it works. So what is all of this then basically? And if we think about the last couple of lessons that we've done and the last couple of kind of assignments that we've done in relation to trying to get you to think about how science works. So this here, the scientific method, you can kind of boil it down to this flow diagram here. This is a summary of how science works. Now remember, scientific ideas, they're not static, they actually change over time, well, depending on if new evidence comes along. So all science starts with curiosity. So scientists are people who are curious about something in their environment, and they start to ask questions. So they might ask a question, for example, how does the water cycle work? So that would be a question. And what they'll do then is they'll go and they'll research everything they can. They'll try and find every piece of information they can about the topic that they're interested in studying. So they'll go about and they'll do a little bit of research on like what's known about, for example, the water cycle or whatever it is that they're interested in. Then what they'll do is they'll have a specific question and they'll turn that into a hypothesis or a suggestion or an explanation. So they'll turn it into an if-then statement. And then what they'll do is they will test the hypothesis by carrying out an investigation or an experiment. So they'll come up with some way to test the hypothesis. So remember, there's certain questions that are suitable for science, and there are questions that can be tested to determine whether the answer is true, whether the question is true or false, or the if-then statement is true or false. So they'll carry out they will test the hypothesis by carrying out an investigation or an experiment. So once they've kind of designed the experiment, they'll carry it out and they'll collect the data. So they'll gather up data and they'll analyze that data. And then from that, then they will form a conclusion or an evaluation. And then based on that, so if the hypothesis is false, then what they can do is they can go back and they can look at a new hypothesis or form a new hypothesis. So they can say that, well, this way of looking at it isn't accurate or it isn't true, so we need to change the way we're looking at it and test it to see if we can come up with a different explanation or a different hypothesis. So what they'll do is they'll keep doing this until they kind of come along and find the correct answer or the reason for why something is the way that it is. And once the hypothesis is true, then what they'll do is they'll take that information, they'll take all of the procedure they used and the analysis they've done and the data that they've done, and they'll report the results. So they'll basically show the results to other scientists around the world, and they're not showing it to other scientists to brag and say, oh look, this is great. They're actually showing it to other scientists they want other scientists to poke holes in their investigation and try and show that what they have proven is incorrect. And that's how science works. So basically what they will do is other scientists they'll all look at what the particular team of scientists or scientists came up with, and they'll try and determine whether it's right or wrong. And they'll basically tear it apart and try and look for where it's wrong and where there's mistakes in what they've done. And what they do, how do scientists report these kind of ongoing research or findings? They report them in things like in journals. So this here is what's known as Nature. So it's one of the biggest scientific journals that we have, and you can actually go online and you can have a look at some issues of Nature. Okay, so it's basically an area where scientists post their ideas or investigations that they've carried out, and other scientists go in then and uh, they review, for example, the work that the particular scientist has done. So scientific ideas evolve and can change over time. So they're not static. They actually can change over time. Uh, the way of doing science, the scientific method, can be applied to some of the things you are curious about. So what's important is, to take away from this, is basically the way that scientists work. So this is kind of, they use this thing called the scientific method, and they can come up with explanations on how the scientific method works. And what we're going to look at, as I say, we're going to do an assignment in relation to the water cycle, and we're going to reflect, we're going to carry out an experiment, then we're going to reflect and think about the kind of skills that we've learned and what we've learned in relation to the experiment that we will carry out. Okay, so that is that. So again, students should be able to review and reflect on skills and thinking used in carrying out an investigation, and apply their learning and skills to solving problems in unfamiliar contexts. So this is what we're going to look at. We're going to look at developing a model for the water cycle, and then reflecting back then and seeing what we've actually learned about the water cycle by carrying out our investigations.